So now that we finished our introduction activity, we're gonna kind of work a little bit more with our physical and chemical properties. So what we're gonna do is an activity. This activity is gonna be in groups of 3 or 4. You all can pick, try to mix up a little bit. You want to place the two cards that I'm going to give you, the ones that say physical property and chemical property, at the top of your desk. We'll talk about that again on the next slide, just so you have an example. I'm passing them out right now, so you'll be able to start, once you get into your groups, putting those at the top of the desk so that you can all see. What you're going to do then is with these extra cards I'm about to give you, is sort the image and word cards into each category. So you'll be able to see what I mean here on this next slide. So up here at the top, you see we have chemical properties, and here's a physical property card. These are going to go at the top of your page or at the top of your desk. Lay them out so that your whole entire group can see them. Then you have your example cards. These are ones that you will have. There will be additional ones as well. But what you're going to try to do is sort these into either chemical or physical properties. Now, these are not sorted correctly, so don't memorize this layout because these are not correct. There might be some that are, but most of them are not. So for example, here we have a picture of blueberries. The property that I want you to look at is blue. It's the written word right below the picture. Here we have a fire going on. This is combustible, okay? Wood is combustible. Rocks would be hard. This metal is rusting. This, whatever chemical it is radioactive. And a lemon is sour. So use these words and these pictures to help you figure out whether they are chemical or physical properties. Remember that what we talked about at the beginning of class, kind of the ways that you can categorize them, things that you can look for, maybe the senses might help indicate which one of these it would be, whether the substance is changing, not changing. So bring all that together and see which you sort into which category. Okay, we will check those at the end. So you can get in your groups and start. This is a side note. Since I don't have students, the first thing I would want to do is walk around encouraging discussion, just saying, hey, make sure you're getting involved. I see this person's not answering any questions, not really actively participating. Encourage them to try one, discuss with the group members. Some of the questions I would be asking students is, like when you look at your card, does it have one of the five senses included into it? Like, can you tell what that is based on your five senses? Um, is the material changing? Is it staying the same? Uh, does this ever vary? And just asking certain students, okay, look at this card. What does it say? What is it asking for? What do you think? Especially ones that aren't really participating as much. See what they think. See if they have any ideas, if they want to kind of discuss with the group, get their input on it before they make a decision, but really just trying to encourage everyone to work, making sure that they are all actively engaging in this portion. Uh, I would give them probably a few more minutes to work on these. It should not take them too long, especially since they're in a little bit bigger groups. I put them in the bigger groups so that they can kind of discuss with multiple people instead of just having one person and another. This would especially help ELLs because they wouldn't have to be the center of attention the entire time and they can kind of listen and hear how the other people are discussing. All right, class. So the answers to our activity. These are some of our answers. We could go over the rest at a later time if you guys want to. The first one we're going to look at are the physical properties. So here we can see that the first thing I categorized in the physical property is blue. Why is that a physical property? All right, good. It's because one of our senses can figure it out. We can see it. It's blue. Okay. The next one is hard. Why can we tell that that one is a physical property? Good, because it's hard. We know rocks are hard. You throw them at things, they can break things. If you step on them where they don't just crumble under your feet, they stay together. And last, we have sour, and that's a lemon. So why would that be a physical property? Right, because when you taste a lemon, it tastes sour. So you can tell that pretty easily. Chemical properties. Now, one note, some of these you can tell what's happening because of sight, feel, touch. Um, but the one thing is, these things are changing. Okay, the materials are changing. When you burn wood, what happens to it? Right, it disappears. It turns into ash. It turns into something different. There's not wood left there after it burns. So when something is combustible, that means that it has the ability to catch on fire. It can burn and turn into something different. Rust. Is there a change happening here? Right, rust occurs when metals are left outside in wet areas. A reaction is happening. So it's changing from that original metal and it's combining with oxygen in the air. And that's what's creating the rust. So the ability to rust is a chemical property. Can everything rust? Right. Food doesn't rust. Wood doesn't rust. Concrete doesn't rust. Only certain things rust. So that's a property that things like metals have. And radioactive. That's a chemical property because not everything is radioactive. Uh, when things are radioactive, they're kind of dangerous. Uh, this means that the molecules are doing things that aren't normal. They're not supposed to be doing that. And it's potentially dangerous. So this isn't necessarily something you can see with your eyes. You can't really feel radioactive things, or you can't feel the radiation coming off of them. You can't smell it. You can't taste it. You can't hear it. It's kind of like invisible, but it's there and it's a property and it's something that you can test for. So we're going to briefly watch part of this video. It's going to go through some common physical and chemical properties. Once we see that, we'll talk a little bit more about them, and then we'll get into some activities.
Hello, B here, and welcome back to properties fall into one of two categories, physical properties and chemical properties. Thinking back to the honey earlier in this lesson, we were able to easily describe its color and viscosity. Color and viscosity are examples of physical properties.
So we skipped the beginning part, color. That would be like amber. It'd be maybe yellowish, orangish. And viscosity is how thick something is, specifically a liquid usually. So honey, is that thick or is it kind of thin? Does it run really easily? Right, honey would be thick. Can anybody think of any examples that would be similar to honey that would also be thick? Okay, maybe oil. That would be a good one. Tar, that's a good one. So now we see that thicker liquids have a high viscosity. What about thin ones? Can anybody name some thin ones? Good, water would be an example that flows pretty easily. Maybe rubbing alcohol. We've seen that flow pretty easily. All these liquids you can see flow differently. And that's a property that we can use to tell how uh, how viscous it is, how to determine the property that it is, how to determine what substance it is. So all of these contribute to physical properties. That's things that you can see, touch, feel, all of that.
Physical properties are properties that can be observed without changing the chemical composition, meaning you don't change what the substance is, but rather make observations based on what you see. Can you think of some more examples of physical properties? Some examples include color, shape, and mass. What about density? Can you find the density of this metal without changing it?
Let's first talk about color, shape, and mass. So the color of this block, it would be what? Silver, shiny. Can you see through it? No, so it's not transparent. What about the shape? Good, rectangular, like a rectangular prism. And its mass. Do we think this is going to be heavy or light? Good, it's going to be heavy, and we can weigh that on a mass scale, or we could figure out its weight, uh, and then we could figure out maybe the composition of it based on its weight and how much of it we have.
Yes, you can by calculating the volume and measuring the mass. What about boiling point and freezing point? Using a thermometer, you can measure the boiling point and freezing point of a liquid, and, as we learned in a previous lesson, there is no change in the substance during phase changes. The particles are just moving slower or faster, causing the state of matter to change. This means that boiling point and freezing point are also physical properties. Another example of a physical property.
These ones are a little bit different from the ones we talked about before. So boiling point and freezing point. I thought we said things that are changing are usually chemical properties. Well, the one difference here is we're not actually changing our substance. Okay, let's think about water. Water has three main phases: ice, water, and steam. Okay, we know it's a solid, liquid, and a gas. When it's ice, is it any less water? No, it's just a little bit different. When it's a liquid, does that mean it's different from what's up in the clouds? No, those are both the same too. It's all water. So even though a change might happen here, it's still a physical property, and that's because it's still water. Okay? These ones you can't necessarily find with the senses as well. This would probably be something that you would test for, but a majority of these you can test or physically see. You don't need to test. The ones that you need to test uh, can also be physical properties.
Property is the ability to conduct electricity. Have you ever tried the good old lemon or potato as a battery electricity experiment? Well, in these situations, the lemon or potato are not changing while the electricity flows through them. This means conductivity is a physical property.
Conductivity, that's another one. That would be something that you could either test for, try to figure out whether that substance is conductive or not. That is a physical property again, because that doesn't change what you have just because it conducts electricity. For example, the wires that bring electricity to your house or the school, those don't change what's inside of them when there's electricity flowing through them. They're just moving electricity. There's still metals in there. Usually they're copper. So they stay copper. They don't turn into something else. It'll always be copper. So that's a physical property.
Is a physical property. These two flasks contain the same exact liquid. Looking at them, we can determine two physical properties: color, blue, and volume. The flask on the left has a volume of 100 milliliters, and the one on the right has a volume of 75 milliliters. Even though both color and volume are physical properties, when the amount of the substance changed, the color stayed the same while the volume did not. Color is a specific type of physical property called an intensive property, while volume is an extensive property. All physical properties are either intensive or extensive properties. Intensive properties are properties such as color, density, and freezing point. These are all properties that remain the same no matter how much of the substance is present. On the other hand, mass and volume are examples of extensive properties. These are properties that depend on the amount of the substance and will change accordingly. A substance's chemical properties are a little harder to notice than its physical properties. A chemical property is the ability of a substance to change its composition to produce new substances, meaning that at the atomic level, you end up with a different substance than you started with. That means chemical properties can only be observed when the chemical composition of the substance changes. Examples of chemical properties include a substance's reactivity with other chemicals, such as water and oxygen, its flammability, and its ability to rust. Where physical properties can be divided into intensive and extensive properties, all chemical properties are the same, no matter how much of the matter is present. Why do you think that is?
Okay, so we saw a little bit about physical and chemical properties. Let's just talk a little bit more about them in case you missed anything that was said in there. So physical properties. These are usually based on the five senses. So see, hear, touch, taste, smell. All of those can contribute to helping to figure out whether something is a physical property. These can usually be measured and observed. So we could measure them. Maybe if we're taking the volume of something, we measure it, and we can observe, we can point at different things that we see. Sometimes this needs to be done in a lab, like for the melting point and boiling point, or conductivity, but we can still kind of observe those properties occur, and then we can see when they happen based on the temperature, whether it lights a light up. In this type of property, the substance does not change. Doesn't matter how much of it you have, the substance does not change. So if I have a drop of water, or if I have a glass of water, or a pool of water, we still have water. Chemical properties, though, these are based on the interactions of substances, okay? How they interact with the environment, how they interact with other chemicals, other substances. We don't need to know anything about this reaction, but what we can see is this little thing is hitting this atom, okay? What it causes it to do is break into different things and then break into even smaller things. The ability to do that, atoms don't usually do that. Some do, and they will release radiation, and that's a chemical property. Not all atoms do that, okay? Another one, we see a reaction happening here. We can see something is going on. This substance is probably changing. It's letting off a gas. So this gas being formed tells us that this is a chemical property, that it reacts with whatever you put it in. These can be observed or tested, and this usually happens in a lab. Now, not always. Combustibility is a little bit easier to perform on your own, but to tell whether something is radioactive or if it rusts, usually that's not easily done just at home. You would need a lab to speed those up or to figure out and measure how much it's occurring. In these examples, the substance does change. Here we can see this metal pole. There's a lot of normal metal. It didn't react. This iron is still there. But here, some of the iron changed. It's now this deep reddish, brownish color. And that's because it rusted, it reacted with the air. So that would be a chemical property, the ability to rust. So we have some more examples here. I'm going to pass out the sheet to all of you. So you will have this, keep this in your notebook so that if you want to reference it in the future, if you ever kind of get confused on what physical properties or chemical properties are and some examples of them, then you could use this to figure out what the things you're observing might fall under, which category they are. So color, physical property, size, we can see big versus small, hardness, rocks are hard, bushes are soft, luster, so how shiny something is. This penny's super shiny, this one's dull. States of matter, whether it's a solid, liquid, gas, those are all physical properties. Chemical properties would be example, if it's flammable, does it combust? Can it burn? Can everything burn? Maybe, but do you ever see the road catch on fire? Do you ever see metals catch on fire? Not very often. So usually they're not very flammable. Toxic. Okay, some things are toxic, some things aren't. Is air toxic? No, that's good for us. But if we're breathing in carbon monoxide, that is toxic. Corrosive. Has anybody ever seen an acid get poured on something and it kind of eats away at it? There's some really cool videos of things like that happening. Uh, One example is what happens in your stomach. Okay, your stomach has acid in it. That's how you break down your food. So that stomach acid is corrosive. It breaks things down when they touch it. pH, this is something we'll talk about a little bit more later on, but this is just how acidic or basic something is. And last, we have if it's radioactive. Does it let off radiation? Is it dangerous to be around? That is an example of a chemical property. So you'll have all those sheets to remember and to reference if you need. These are going to be really common ones. There's obviously a lot more, but these are the ones that we're probably going to focus on the most throughout the class. So the last thing we're going to end with, I'm going to turn the class over to you. You have an option between 5 different activities. You can pick one of them and complete it, whichever one you feel the most comfortable to do. There's different ways of learning and practicing all of this stuff in each one, so you can try them and see which one you like the most. The first thing you can do is create a video with any substance you want. Just find one and describe its physical and chemical properties. Try to find a substance that you can name a decent amount of physical properties and 1 or 2 chemical properties. Okay, do you know this thing rusts? Do you not know that it rusts? Things not rusting is a chemical property. It doesn't have the ability to rust. That's something that we know about. If it doesn't burn, okay, that's a chemical property. The next option is to take this sheet of paper that I have with a list of properties and write down a substance that has the property. So for example, if it says, is silver in color? Okay, that could be lots of metals. That could be lead. Okay, that could be chrome. Any of those would be good, good substances that match the property. The other option, you can go to the lab. There are 3 unknown substances. You will not know what they are until you're done. And you need to write down and test for some of their chemical properties, which the procedure is in the back in the lab. And you need to observe their physical properties. Okay, we're going to focus on the sense properties for their physical properties. So all you need to write down is what you see, what you smell. We're not going to taste them. We don't ever taste anything in the lab, and how it feels. The next one, you could take this quiz and you need to score above an 80%. I'm actually going to go over this one last because I'm going to show you what you can do on this quiz, which is pretty cool. And last, you can write an essay outlining what you know now about physical and chemical properties. So just write out what you know. Write out some of the differences, some of the similarities, some of the properties of physical and chemical properties that you know, maybe some examples. Whatever you can think of, just show me what you know in about 100 words. So looking at this quiz now, let me pull it up. So if you start this quiz, one really cool thing that you can do is go up here and hit translate page. If you're having trouble understanding what's going on, then what you can do is select translate from English and pick whatever language you want. So let's just say maybe French. You hit translate, and the really cool thing is you can now see it in a different language. So you can figure out what it's saying if you're having trouble and answer these questions. I really want you guys to be familiar with physical and chemical properties and knowing the difference and how to determine them. We're going to be using this throughout the year in different labs, in different activities. You're always going to be writing these down, observing them. So it's something that you really want to understand and know the difference between. So that's all I have. I'm going to turn it over to you guys. You can work on your assignments. If you have any questions, feel free to ask. If there's anything you want to change, you need help on, that you want to understand better, feel free to ask. And good luck. Thank you for paying attention, and I will be around to help everybody.